Good morning, hello. Hi Bear Cool Cow says Muma. How are you doing today? I noticed you've been streaming a lot at my nighttime, which is like less than 12 hours ago. Less than around 8 hours ago, 9 hours ago. That's usually when like I've seen you've been streaming recently. Haven't been able to catch it because that's usually when I'm starting to head to bed. Doing my night routine and all that stuff. Oh no, an ad kicked in. Of course it did. Of course it did. I've purposely not been playing ads. But then they have like that pre-roll ad thing in my dashboard, which I can look at. It's like, okay, if I were to play an ad like right before the stream started, I guess like during the starting soon, then that would mean that anybody joining in would not get an ad. It's like, I guess I could try that maybe someday, but Hi Bear, Skitties, Skittles, skateboarding. Oh yeah, all that stuff. Well, hopefully it was a good ad. All right, let's take a look at what we're doing today. Where's our code? Oh, I'm in VS Code right here. We are looking at, did we make our update in here? We did. Check the systems one by one and make sure that they are working. So this is sort of what we've gotten to this point. And so now it's like, okay, all of these are sort of broken, which is cool. Okay, so we have this handle screen size change system. Let's go into it. Take a look. All right, so we add, right, so clear mesh. Now, oh, you're starting around 2200 your time, which is Eastern, till when Toggle Bits gets on 3 to 4 hours later. Aha, okay. That's, see, Eastern time, 2200, that's like 10 o'clock, 2 hours. Okay, so that's 8 p.m. my time. I'm like finishing up. That's like my fun time for the night. Isn't a set schedule just intentionally keeping it short? Why? That isn't a set schedule. You just been intentionally keeping it short while you warm back up to it. Oh, awesome. Eventually you're gonna get, well, I haven't been able to catch your streams. Have you been working on your, the events app? The events, is that what it is? It was like the crate for handling Twitch events, which is fun because our API is separate from the one to handle chat. PubSub, yeah, that's what you called it. Let's see, create clear mesh. You know, oh, okay, right, handle screen size. So clear mesh. I decided not to do the clear mesh thing anymore. I don't need to do this. So it doesn't need to be in a block like this. We're just gonna get rid of it. The reason I'm gonna get rid of it, I got some like some suggestions that it didn't actually look that good, and so that's why you may have noticed I like sort of disabled that when it was running. So I'll just remove it. It's no need to have disabled code. Wrapped arena size, world. Okay, so okay, so now we have this like get resource stuff. So we're gonna get the arena size resource. How does this work? No method name get resource found for mutable reference. All right, so what is it? How do I get the resource again? Right, oh, it's get resource for a very specific type. That's what it is. I haven't touched it in a while. You've been messing with the front end you have for it, which is a TUI on screen thing. A GUI on screen, TUI. That's cool. Let's see. Oh, a terminal mode. Oh, it's a text user interface. Nice, nice. I am Hardliner. Hello. Okay, so how do I want to do this? I need to tell it what type it is. So, oh wait, do I need to import? Oh, I do need to import that. So that way it knows. I need to do that. So that way it goes the into. We get an unknown out of here. So I don't think we bar. Okay, so what happens? I think our problem here is that we don't know what we're getting, right? Expected stir found in enum for world get resource in here. Oh, right. And I think what we want to do is the same thing. So we want to have like a string, and it's into, but in this case, it needs to be a static stir. And then you're gonna be this S. And you return T. Would help. I wrote that correctly. Okay. All right, so let's see, we got get resources here. So now, oh, that's of course gonna mess all of this stuff up. So what do we want to do? We want to do an S into, actually I should just copy and paste, shouldn't I? Oh, and everywhere there's a get resource, we can now do this. In fact, I can replace the entire get resource line like this. So wherever we have get resource, now come to the beginning, go to the end, like that. Okay, so that replaces you. You don't seem to be happy with me. Not all trade items implemented. Missing get resource. Oh, I forgot the function. Okay, we have you. Now what? You're upset because the T is the first one. There's an enum variant. No, a type parameter with a similar name exists. I'm gonna find type T. Right, because you're actually a point. So I have to change you everywhere. No, because you're not a point everywhere. Come on, what am I thinking? You're a color here. You're a mesh here. You're a U32 here. You're an F32 here. And you're a U size here. Okay. All right, so we got that working now. So for handle screen size, we want the arena size. It's not satisfied. Required because the requirements of the impl. Right. Let's see. In world methods. So. Into static stir. Okay, so we need to fix you. You can't just be. Right, so we have into for the string. We now need to impl into static stir or resource names. Into, okay, we return this thing. We're going to return a match self. All of you. We do have to make sure that they're the same name here, but it looks like what I just took is this exact same name and just bring it over, so that way I can do the exact same thing here. So copy all of you. All right, and that's it. So then you should be happier. Type annotations needed for T. Type must be known at this point. So now can I say that you're going to be a type arena size? You're a point. Okay. The treat bound static stir convert from whoa, you're trying to convert the point to the static stir? Oh, that's not what I wanted. Did I do that wrong for the type point? So if I come here, we go to so here's point. Get resource, we have S into, so name is S, and we return the point. Oh, this. Okay, because to get resource, we give the type of U. Okay, hold on. So in U, you're going to be a resource names. Type annotations needed for T. Type must be known at this point. I need to give you here, I guess. So you're gonna be what are you returning? Oh, so I guess like a point. You're returning a point like that. Okay, so that makes you happy. I'm not completely convinced that we have a point yet. So I want to come back and see. So we have this get resource for point. Yeah, this is not doing anything here. And I'm not convinced that we're actually going to be returning a point. So we may have to update that. Let's take a look here. So we have get resource, green screen fail. Oh, cameras. Too low, is that, that's that side. Am I seeing? Yeah, you're seeing the floor. So you can stop falling, and you maybe? Yes, there we go. Okay. How to unplug and replug the microphone back in. I don't know why that... Weird things abound. Anyways, I was asking, how do you like your standing desk? All right. Get resource. Okay, so you like it very much? Nice. Do you have like a foot? I don't know what they're called, like a mat, a standing mat? I have one that goes under mine. I like that a lot too. Okay, so get resource. You have mat, you don't really use it. Yeah, I use mine a lot. Only if your legs are tight. Okay. My feet get a little bit tired if I don't use it, so. All right, so this is world methods for point for get resource. Excuse me, get resource in here. Let's do a to do. So we can come back to it. Let's then head out to, okay, so in world methods, we need to get into the resources itself. So I think that's going to be the resource. No, it's going to be the resource data. So here we have this resources hash map. Get there. We have this trait for get. That's fine. We're only getting, we're not mutating at this point in time. So we need to use this trait. Okay, so impl, what do I call it? Resource data lens. Resource data lens for point for resource data. Implement you. Okay, so now we know that it's a point. We're gonna get this back. Now the question is, are we gonna get a point back? Because I'm not actually convinced we're gonna be able to get the point back. I think we're gonna have to get the wrapper back. I think we're gonna have to do this get resource data back. Yeah, I think that's what we're gonna have to do. And then we're gonna have to cast it. Yeah, back at the other source. Okay, so that being said, like, does this need to be wrapped in this way? Like, I wonder if I can get away with just having resource in here. That might work. That might work. So if I just have the resource here. So let's so we have resource data. So what if we just do resource? Like, this is all we're storing in here. So in insert, we just do the resource that we were throwing in. And so then this is going to return the point. This is going to return a resource. It has to return a resource. We have to do the cast elsewhere, I think. Is that true? Maybe it cannot be. Okay, so let's say we do that. Then we're gonna have to get this out. So we're gonna say let source is equal to self dot resources. Is that what I call it? Self dot resources dot get. This is gonna be our key, which is our name. Let's just go ahead and unwrap right now. So that gives us this resource. If I attempt to cast, at that point, and you think that I want it to be a U32, but I really want it to be a point. So can I say that I actually want you to be a point? A reference to a point? Mismatch types, expected reference, found reference. I guess another question here is for cast. This is in resource. Oh, well, that's a reason why I don't have resource cast for point. Okay, so implement you. We're going to cast for this. Okay, so here's how we're going to do it. We're going to do a if let resource point. So your point is equal to self. Then we're going to return the point. Else. We're going to return, we're just going to panic for right now. We do have a story to sort of like change this. So, don't have, I am not a point. Okay, so if I do that, then back to you. I don't even think I need to do this anymore, do I? Now I just need to return the resource. And it knows exactly what type it is. So that gets us out of here. So if we just don't store this in exactly the same way, because it should, like, I think that we can get away with this. We're gonna find out really quickly. All right, so if we do that, now we have a get in here for there. Then we're going into, okay, so get out of here, so get resource. For our point, we're gonna do a self dot resources dot get, pass it in the name, and we return this point. Expected this stir. So let's do an into here. All right, and then we should be able to go back out to this handle screen size. Now I'm really curious. Okay, so how are we gonna do this? Do world get resource, source names, arena size. But arena size equals the wrapped arena size. We cast the point here. I think I don't need to do this anymore. So let me go ahead, move you. So, oh, because you don't know what it is. So you need to be a reference to a point. You figure out what you want. Then we have this arena rect. You can just be arena size at this point. And then you're happy. And we don't need the mesh here. And that allows us to head back to here. And we have the handle screen size change system is done. Okay, so next up, get the resource from this. So what do we want? We want the borrowed update FPS, self the world, get resource. We have to see, get, oh, add that, yes. Yeah, we have to do the resource names. Pass that in. Don't think we do that because we have an into for you now. We have a semicolon there. This is going to be the update, just a pure update FPS. We don't have to cast you either. Okay, so then you're an unknown. So I want, if we're just going to do a get resource, then you're going to be a reference to a, what are you? Like, what is the type that this needs to be? It's a U32. All right, so that makes you happy. And then what are you? Expected. Okay, so then you can be a dereferenced here. Okay. Now we have this update void color system. All right, errors abound. Okay, so get resource. We need the color for this. All right, so what are you going to be? Color change every. Oh, it's not color change every. So color change speed. Are you an F32? No, I don't think so. You're a U size. Okay, so if we do, oh, maybe this one will auto figure out because it knows what it's supposed to be down here. Okay, so world get resource. We have to give this world methods to add you. Resource names. We have to take you away. We semicolon you, and we get you away. You're off the bed, Bear. Thank you so much for stopping by. I know it's pretty late for you. Maybe one of these days I'll stay up late enough to actually watch your stream for real. But yeah, have a good night, morning, sleep time. Oh, it's 9:25 a.m. Oh man, we're up all night. Okay, so that, oh, it's unknown now. So it doesn't know how to deal with this, even though color change every should be, yeah, it's trying to be used here, but it may not know what it's supposed to be. So we have to say that you're going to be a reference to a U size. Okay, so then we have this color change rate. You're a cast F32, so we know that you need to be a reference to an F32, because I don't think we're going to be mutating you. Yeah, we're just borrowing you. So world, get resource, that, resource names, review, semicolon U. Okay, so that should give you out. Okay, so then the wrapped void color. Okay, so now we need to get the actual color out. because we're going to cast color mute. Okay, so this needs to be mutable. So this is going to be fun. You're going to be a type mute color. Okay, so world get resource mute. We're probably also going to have this resource names. Remove this from there. And then we're not going to have to do this entire thing, and it's just going to be the void color. Okay, so now you're just saying, hey, you don't have this method. We need to go deal with that. So we're going to need to go to the world. Go to the world. And so we have this get resource. We also need a function get resource mute. So here's the question. Here's whether or not it's really gonna be a problem. Is can I do a mute self? If I can, then we're all good. Okay, so then we're gonna have this name, which is this S. We're gonna return. This is. Okay, why am I doing this in point? Why did you bring me here? I want you to be in the world methods here. And we're going to return a mutable reference to T. That's it. Now I want to come back to update void color. So we need you to be mutable, which means I need to head back to the library and update void color, mutable. So you're not yelling about this to me yet. So right now we have all the problems over in here. So let's go ahead, delete all these missing members. Okay, so we're gonna do this for color. In order to do this for color, we also need to go into the resource data and have this lens for get mute. Function get mute. Okay, so get mute. In order to get mute, we also need a cast mute. So that's in resource. Trait resource cast. Why are you upset? Function cast. Mutable self. Cast mute. Mute. Okay, now you're going to be upset here. I'm going to implement you for that. Implement you for that. Okay. And then we're doing this for a color now. So let's go ahead. resource cast. This is going to be a color. All right, so, okay, so for cast, we're going to do if let, in a way, this can be both of them. Like they're pretty much the same here. So if let resource color equal to self, then return the color, else panic. These are not the colors you are looking for. All right, so that resource is out here. This is in resource. Now we can go to resource data, and we're gonna get mute off of color here. Impl resource data lens color or resource data. All right, so then we have both of these. They should be exactly the same for how to implement them. So we should be able to do self dot resources dot, oh, because one is going to be get and one is going to be get mute. So that's going to be a pretty big difference. So get, so hold on, I'll update you yet later. All right, so we're gonna get, the key is gonna be the name. And then unwrap and cast you, and you should figure out what you need to be. Can I find type color in a scope? Well, there you go. All right, so now we're gonna do the exact same thing here. So resources dot get mute, pass it in the name, unwrap you, and then we're gonna cast. Not cast, we're gonna cast mute. So get mute, you need to be mutable here. Okay, that makes you happy. Let's go up one more. So we have resource data, we're going to the mod, the world method. So now we have this get resource mute, and we want to do the one for color, I think is what it was, to get resource mute. Arctic Space Fox, hello! How are you doing today? Let's see, let's go ahead, and now we're going to do a self dot resources dot get mute that, pass it in the name, and then it returns the thing that we want it to return. So that's it. Oh, and name has to be an into. All right, so there is that. Now we go one back, which is the update the void colors. And now we get the void color out of here. Perfect. And then we can update the void color. All right, back to the main library. So now we've done the update the void colors. We take a look, we're just slowly fixing all these problems. Wonder if it'd be easier for me just to do this. Okay, this is the main library. We have the get resource. Convert from, right, so you need to do that. Type annotations needed. we need to do that, and then resource names. Type must be known at this point for T, I think. So we have to say this resource that we're getting out. So what is this? This is a color. And we're just borrowing it. So it's gonna be a color like that. That. Okay, so that gets you out. Graphics clear. Okay, so the background color. Oh, hold on. I don't need to do this entire rigmarole. So it doesn't need to be in this block. Background color. So you're going to be a reference to a color is equal to self.world self.world dot get resource names, the background color, and that's pretty much it. That gives us this, whatever. Oh, if self has resized. Okay, so that goes there. There you go. Now we have, okay, graphics clear. You need to be an actual color. So I think you implement clone and copy. So I can just dereference you and you'll auto copy out. Okay. And then another one of these get resources. So this is the wrapped screen size. It's going to be turned into a mutable point. Okay, so we need to deal with that. So you're going to be just a screen size equals. So we need to tell you what you are. You're a mute point. Okay, self.world get resource. We need to tell you resource names, remove you, semicolon, and remove that. Mismatch types. Okay, hold on. What did I do wrong? So mutable point. Expected mutable reference, mutable found reference. Oh, get report resent mute that. Okay, that makes you happy. Now I have a bunch of those to-dos, so when we actually run this, it's probably going to crash. But at least like the compiler will be happy. Then we have to just update those methods, which will be nice. All right, locations wrapper. So now we're into the components and querying. So we need to be able to query now from these, and I don't think we have that set up. So what is it that we need to do? We need to figure out, okay, so let's come in here, see what we need to do. So we have world. We have our struct world, and we see we have their entity data, and we have our world methods. We don't even have a query on here. So we need to figure out how to implement the query. However, in entity data, we also need to query for this in here. We just have insert, but here's where the components are. So we need to query out of this, and we're going to give the ref cell, the RC ref cell of components. And then we can cast once at that point in time, I think. Because I can't borrow in here, unfortunately. So let's see. What are we actually querying for? Oh, that's in rust up. Don't. Okay, get resource. Oh, okay. Well, I can fix the get resource. This is just a cast 32, so you're going to be a reference to an F32. World get resource for you. That. There's names. Review. Semicolon. Okay. So make you happy there. All right, so now we're back in here. Okay, so it's alignment that we're having the problem on. We need to get a location out. We know that a location is a point. So we need a query one for a point. What is that gonna look like? Let's go all the way in and figure out, like, I guess our casting first. So this is the components here. So in our enum components, we have this like point and F32. So we have our cast mute for attraction. Locations, we're not mutating the locations. They can be non-mutable. So this is going to be a function just cast. Okay, so can we do that? Feature view, we need to implement you. And then for a point is what we're caring about here. So what does that look like? So if let components point equal to self, then we're going to return point. I guess it's points in here. All right, so that gives us a points, just a vector of points, or a reference to a vector of points. This is in components, so now we're going to go to the entity data. This is now in this trait, we have insert, so now we want a query one. So function query one. We're going to have a reference to self because we're not mutating it. And do we need the name? We do need the name. And so if we need the name, you need to have this entire S, which is into static stir, like that. You know what also makes sense is I could just have this be into string. Name is an S. Now, what are we going to return? What are we going to return? We are going to return an RC ref cell of components, aren't we? Because I don't know if we can get around that. I don't think we can cast inside of here. We found that out because we can't borrow in here. We have to borrow where we use it. So we can't get away with this. We're gonna have a ref cell and then a components in here. So we're gonna do that. I can't remember if you're a reference. I think you are. Let's actually do this then for the point. Implement missing members. All right, so for point, we want to then self dot components dot queer get pass it the name. So here's what I'm gonna do. I'm gonna do a reference here and into like that, and that will be happy. And then we're going to unwrap and return what we get out, which should be this. All right, so then we go back into world and we need our query. So in world methods, we have this function query one. Okay. So hold on, in this, where was I? In components, I don't want to make you do that. You can just, world can handle like the cast for you. That's not components, entity data, query one. Yes. I don't need to do you here. So here, in query one, we're going to update the signature. Remove you. Go into self, name, instead of S, you're just going to be a stir, like that. And then you return this is the entity data. Oh yes, this will be fine from there. Okay. Send and get. Type annotations needed, cannot certified, string standard borrow. Right, I don't need that there. I don't need this into, it could just be the name. All right, so then we're happy here. We're gonna head back over into the world. If we're gonna have a query one, here's where we're gonna do our S. We're gonna have this into, and I'm thinking we're gonna do a string here. Self name is S. And this is going to be our T. So it's not going to be quite the same back out, is it? We have a T, so you're actually going to be a reference to an RC. Ref cell, and then in here we have the components. That's what we're returning. Does that do for them all? No, it did not. Okay, that's too bad. All right, so what are we doing this for? We're doing this for a point to begin with. Let's see how this works. We have this query one, and it turns out like this, I may not want, this may not be necessary because I have to return to components anyways. You know what? I'm gonna undo that. Let's remove you. Okay, so in query one, you actually don't go in world methods. We're gonna have to put you just in the import world. Hub function, query one, we have this S into string, so we can just take whatever we want, name S, and we return this thing. All right, so how is this gonna work? We're gonna do a self dot entity data dot query one from you, and then pass it in the name, which is going to be a reference to the name dot into, and then just pass that on through. Type annotations can infer type for parameter t. Yeah, so like no matter what, I can't do the cast in there because of this RC ref cell. That's our problem. I am able to do the cast on the resource, but not the components. So let's go back into components now. We have the entity data. So query one doesn't belong in here. This belongs in just the import entity data. So we can just take you and put you here, which means actually in this way, you come up here. You go away, and you go away. See, I can't get away from that cast. Because we have the RC ref cell, we can't do the cast inside, like unless I'm cloning or something, which I don't want to do. So we have this query one in here, so that goes to the mod, which queries one. Oh, associated, you need to be public. Okay, so you're happy here. You're returning your thing. Then we're heading back out to, where were we? I think it was attraction. Oh, I don't remember anymore. Alignment. Okay, so here's accelerations. So world.query one, create component names, acceleration. Okay, so you don't need to be that. You're gonna do an into, oh, I guess I can do these all too. Okay, so we have locations wrapper is world.query one. You. And that gives us this RC ref cell. And I wonder if I can borrow you. So locations, we don't need to update here. So this can be just a borrow. Oscar Ellen, hello. How's the ECS coming along? I think it's going well. Can't make it like look as great as I want it to. Probably not without like a dyn any or a dyn something, which we could look at it as like a future version, just sort of like see if it is any better. Okay, so we have this. This gives us a ref of components, and so we do need to cast them now, but I can cast it once per reference. Mr. Bahan, what is an ECS? Is an API wrapper to AWS Elastic Container Servers? No, it is not. So ECS stands for Entity Component System. It's a really big thing in modern game development. So the idea here is, there. The idea here is, let's say you have like all your locations, and instead of having just like a single struct that has like all of its data and all the methods to update that data, you store all the data in vectors or arrays, if you're familiar with those. I guess you'd probably be more familiar with arrays and not necessarily vectors. Depends upon what languages you're coming from. So we put like, let's say locations. Here's two birds, let's say. Bird 1's location is 5 and 7, and the second bird is 2 and 3. And then we have velocity. So bird's 1 velocity is this. The second bird's velocity is this. Accelerations, and so on. So basically, I know that position 0 in each of these arrays is bird 1. Position 1 is bird 2. And then I can, when I just update these, I can say, okay, give me this, give me all the appropriate vectors, and I'll just update the appropriate ones. It aligns everything into memory. It makes things a little bit faster. It does force more functional style of programming as well. And so that's what I'm trying to get out is, so I've got out this locations, which is this ref of components. So it's not really a wrapper anymore. So locations wrapper. Yeah, so here we're going to like clone, borrow, iter. I think it's just this ref components. If I do that, and now down here, oh, I remember why. I don't want to borrow at this point in time. I need this to remain the same. And that way, I have this locations wrapper. So for location, I can now clone locations, which will give me this ref of components. We iterate through them. I need to cast at this point. So cast. But you don't know what to cast into, do you? How is it more efficient? Doesn't it make functions more coupled? In a way, it actually makes functions a little bit less coupled. But yeah, Epic Blarg is correct. It encourages data-oriented design because like everything is around the data, which is in those vectors. And then we use something called a system, which is really just a fancy word for a function to do one thing. So for example, if we take a look, here's all my systems like alignment, attraction, avoidance. All of those things are just doing the one thing that they need to. So they query for the data out of the ECS system, and then they do the mutations against it, and then that's it. Alignment doesn't need anything or like need to care about any of the other systems. So it's in a way that they're completely self-isolated. Which is really nice. Okay, so locations wrapper, we need to cast you, but we need to also tell you exactly what you are. Let's go ahead and update the rest of these so that way it will tell us what the problem is. So velocities wrapper, we're going to query one into you. Okay. Do your videos on ECS cover it from basics? I did a video series on like learning specs. I think that one probably does the best job. see if I can find it. Where's my content? Because like that's where I was learning it, and let's see. Yeah, there's only 2 of them. So where's the shareable link? There's that. Yeah, I think that's like the best what I have right now that probably like cover, and it also goes into like how you use it. Specs is a pretty good library in Rust for ECS. This one now I'm trying to create my own, so it's like the next level up. All right, so then we have accelerations. So we're gonna query 1. We get here and then we borrow mute. Okay, that's fine. Site range is okay. This is a resource, so we need to tell you that you are a reference to an F32 equal to get resource. We have to pull you in, add you and a resource names. We have to do that. There is no borrow and there's no cast anymore. Also, there's a trick commonly used with ECS, which is called generational indexes. These are thought to be one possible path to create flexible desktop GUI libraries for Rust. What else is an ideal use case for ECS apart from game dev? And I'm also gonna like lump in there any kind of like simulations or things that like feel similar to game dev. It's when you have a ton of data and you want to organize all of your data in memory so that you have the least number of cache misses. And what I mean by cache misses is the CPU has a cache on it. You can actually like see it when you purchase CPUs. They actually tell you what the cache is, like what the size is. That cache is used. It will say like, okay, I need X number, like I need this thing from memory. So like load that up in memory. The CPU will then tell memory, like go to memory and say, okay, give me this little piece of memory, but it doesn't just get that piece of memory, it gets everything around it too. And stores that into the cache. So because we're storing everything in these vectors, it's then storing everything around them, so I can just do, and then that's super, super, super fast. Cache miss is where you load a whole bunch of stuff in, you just used one tiny little bit of it, and then you just throw the rest away, and you go out to cache again. So databases might be able to make use of it if you want to be like super, super, super fast. Besides that, I'm not really sure what the best use of it outside of game dev is. It's not really popular outside of game dev. There's a couple companies using it, but not really big ones. Yeah, ECS is a way to modularize data-oriented design. Absolutely, yes. Okay, so we have get resource, do that, that's fine. Okay, so then we have this turning speed, which is another resource. So you're gonna be a reference to an F32. Gonna get resource, so add you. No borrow and no cast. Okay, so that makes you happy. Now, location. Okay, so I think we have to tell you what you are so that our cast works correctly. So you're gonna be a... What are you? My location is a reference to a vec of location. No, a point. Is that right? It's a good architecture if you have a bunch of entities used by components and systems. Yeah. I haven't run into the need for it outside of this. All right, so what are you expected? Oh, I can't give you a type here. Oh, because this is a tuple. Hold on. Can't do that inside the tuple. I have to do it outside like this. So you're a U size. And then you are a vec point. That. Is that actually true? Cast components, it's not satisfied. Okay, so I need to pull in that. Following implementations were found. So at this point, what do I have? I have a ref of components. So I want, if I have a ref of these components, I want to cast to you to get out this. Hi, come on. We have a purring kitty cat today. Are you ready? Hello, Chantilly. Yes, hello, kitty cat. Zilby is his name. He loves hanging around with us. Sometimes. All right, let's see. Oh, look at this, a vec point? Okay, that's not what I want at all. Oh yeah, that's weird. That's not right. I don't think I could do that. Oh, can I do this? Point. You're a reference to a point. There we go. Okay, you're a reference to vector a point. We iterate, we enumerate, that gives us this thing. We no longer have to do that shadowing. Nearby indexes. Okay, so get nearby indexes. Right, so then we're gonna do this again. So locations wrapper, clone, borrow, and then we have to cast. Here. Mismatch types. Okay, so then we have to do this and to get nearby indexes. My location is this point, but you are a reference to a vec point. Yeah, okay, so you're happy there. And then the site range. We can just dereference you. You'll be happy. Okay, nearby velocities. Get velocities by index. Velocities wrapper dot borrow. So velocities wrapper. So yeah, we do need to borrow you. Oh, but we want to make these like the points. So then we can just cast here. That. Which means we now go to velocities by index and you become a reference to a vec point. Like that. All right, so that makes you happy. All right, so if nearby velocities is not empty. So if there is something in there, do all of this stuff, and we have our turning speed. Just dereference you. Accelerations. Cannot index in a value type of a ref mute. Components. Okay, so accelerations. We have to get into it. So where is accelerations? Up here. We've never cast this. So we borrow mute, and then we have to cast mute. Type annotations needed. Okay, so then accelerations, you're going to be a type of mutable reference to a vec of point. So we don't need to cast you. We just know what you are, and then we're going to add the average velocity. Okay. Perfect. Down here, in get nearby indexes, we have other location. We don't need to do these casts anymore. Like no need for those. And for you, there's no cast point here either. All right, we have one warning. We can just get rid of you. All right, what are you upset about? We have attraction now. Okay, so turning speed, we have a resource here. So you're gonna be F32. Okay, resource names, review, and then we don't need to do this anymore. Okay, so we also have this query 1. So wrapped locations is world at query 1. We don't need you. That gives us this RC ref cell components. Okay. Wrapped locations, clones, borrow, and then we have to cast. Just cast like that. Now we have to tell it what you're getting. So here is this location. We're enumerating. Why am I not handling that? So you're gonna be a usize. Can I do underscore for this for like any type? Like it knows what that is. But then this other one is a vec to a point. Like that. Oh, right. You're not a vec point. I keep on doing this. You're just a reference to a point in each one of these. Okay, so you're a vec of a point. There we go. Okay, and handle location now. Other locations, your ref components, you need to be a, sorry, no, not here. In here, you're a reference to a point. There we go. Site range needs to be dereferenced, and turning speed needs to be dereferenced. Then in down here, location. Okay, so we don't need to cast this location. Okay, so accelerations. We need to query for the accelerations now. So accelerations, I think we have to tell you what you are. So you're going to be a mutable vector of point. So we're going to query 1. Don't think we need to do this entire deref. We're going to borrow mute and then cast mute. Oh, and then not do that. Okay. Then accelerations. Oh, I don't need to do this anymore. We only cast it when we get it out once. I don't need to do this anymore. Right. Okay, so get voids near me. We have index, all locations, site range. So my location is all locations. So where are you? Cannot index. So get voids near me. Where is this? So other locations, this is ref of components. I wonder if I can just cast this like that. And then all locations is now going to be a reference to a vector of point. So then I don't need to cast you. So you're like that. Okay, all locations, iterate, enumerate, folds. So we don't need to cast here either. And don't need that thing. All right, we're slowly sort of like making our way through this and getting rid of all of our big errors. But I think it's working. It's like only slightly cleaning it up compared to what we were like really hoping for, which is like a huge cleanup. So it's not the best. When we add in error handling and like the options, that'll be a little bit more messy in here, but it'll be for the best in the end. That being said, it is after 8:15. I do have to start getting ready for the day. So I'm